Good evening to all of you. Before we start today's session, please feel free to do event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. I will share the event check-in link with the event ID in the Q&A section shortly. Also, we have launched our Reactor group on LinkedIn. Please feel free to join the group to get the latest update on session happening on Reactor. I will share the joining link for that soon. Thank you all once again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. The session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel within 3 to 4 days. I will share the link to our YouTube channel in the chat section soon. Quick word on our code of conduct. We display this at all Microsoft Reactor events that we run, and it's just a reminder to be aware of others. Key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I will now like to welcome Ashirwad, our speaker for today's session. Ashirwad works as a software developer with a leading IT firm. He is an active blogger with the C Sharp Corner developer community. He has also been awarded for C Sharp Corner Most Valuable Professional for his contributions to the developer community. But for now, I'll hand over to Ashirwad to begin the session. Over to you, Ashirwad.
Thank you for the warm welcome, Rashmita. It has been a pleasure to host a talk at Reactor. So let me just share my screen and start this talk. Okay. So can someone give me a heads up that you're able to see my screen?
Yeah,
Yes.
we are able to see your screen.
Perfect. So let's get started. As Rashmita has previously shared a lot about me. So just a small intro. I'm Ashirwad Satapathi. I work as a software engineer. Most of my work has been around building web APIs using .NET Core and building cloud-native solution using Azure Paas and serverless services. Apart from that, I'm a published author and I occasionally blog at my website, codewithashirwad.com. So let's move on to today's talk. So before we jump into the topic, discuss more about what we are going to cover and the whole talk, I just want to list out some of the prerequisites that you need to follow along with this talk. The first thing would be an Azure subscription because we are using Azure IoT Hub and Azure Function to build the solution. The second requirement would be some experience with .NET because the demo is completely based on .NET Core. The next would be some general understanding of Microsoft Azure, though it's not mandatory because anyhow we are going to cover everything on the fly while we're creating the solution. So the next thing would be, what are the takeaways after you attend this session? After the whole session is ended, you'll be able to create an Azure IoT Hub in Azure Portal. You'll be able to register a device in IoT Hub because IoT Hub doesn't allow a device to send data to it out of the fly, right? Out of the box, it doesn't allow anyone to just send data to it. So you need to register a device. How do we do that? We are going to have a look at that. The next would be to create a device simulator. Since we don't have access to any hardware right now, I don't have a Raspberry Pi or an Arduino to, build this service or build this hardware. So what I'm going to do is that I'm going to use a simulator using the client SDKs of Azure IoT Hub to send data, to send telemetry data to our IoT Hub by having a mock implementation of this IoT device. Next, we'll see how we can send messages to our IoT Hub using, again, the client SDKs. And finally, we are going to create an IoT Hub message processor with Azure Function. The work of this processor would be to process the telemetry data, store it inside a Cosmos DB container, and then send an email if there were some anomalies, like let's say the soil moisture level dipped above a particular threshold. Then you need to send an alert to the user to say that your crops need some water, kind of an alert like that. We are going to send an email alert to them. So these will be the key takeaways from today's talk. So let's start the talk for today. So what is IoT? Since we are just a few number of people, I would encourage you folks to share your thoughts about what IoT is. I'd love to listen what your thoughts are.
It is internet connected devices which interacts among themselves using different protocol, and it basically can incorporate anything that is connected to internet, and then that can capture and generate data.
Perfect. May I know your name?
My name is Subhashish.
That's a great answer, Subhashish. Would anyone else like to add up on that?
Hi, this is Nitin here. So yeah, IoT, it enables the organizations to analyze and act on like real-time data. So this data again is obtained, when systems actually connect over internet and obtain so that they can make smart decisions in real-time analysis, like during their real-time analysis. Yeah.
Perfect. Thank you, Nitin, for your answer. So let's see what IoT is. So here you can see that, I have some set of devices or vehicles or drones, they are pointing into somewhere like an internet or a cloud. And there's this an icon of a brain or it's a human's head. He's trying to process something. Then there's a robot hand, which is trying to do some action. So what Subhashish and Nitin said actually summarize what IoT is. So Internet of Things is nothing but a set of connected devices via internet, which can use different protocols to send telemetry data to a particular storage from where you can analyze and process that particular data that are generated by these devices, and then you can take some data-based decisions to generate some profit or some kind of value. So here you can see I have a car which can be a smart car or a normal car which can send telemetry data about whether all the engines are working well or not. It is trying to send it to a cloud server or is let's say a IoT gateway. So in our case, it's going to be an IoT hub. It's going to send that, and we are going to do some analysis on that and see that whether this particular engine would require a maintenance in next 3 or 4 months. If so, then we can just send an alert or a coupon to the particular user to just attract them to come to our service centers and get the car repaired. Next can be a mobile device. Like normally there is an apprehension that mobile devices may not be and part of may not be come into the criteria of an IoT device, but it very well is, because any device that is connected to internet and has the capability to send data is definitely an IoT device. Similar to the drone. So yeah, that's what summarizes IoT as per my opinion. So there can be various definition, but this definitely forms the core of it. So how does a typical IoT solutions look like? The end goal of our talk is basically to build an soil moisture monitoring system. So it's an IoT solution using which we want to monitor the soil moisture level of our crops on a real-time basis, and get some alert every time our crops need some water. So typically an IoT solution would look something like this. So we have some IP enabled devices. IP enabled because we wanted to connect with the internet, and every time you connect to the internet, you get an IP address of your own, right? So we have some IP enabled devices. All the blocks that are there in oranges are IoT devices. So you can see there's this particular thing called low power devices, which doesn't have their own IP. So this can be anything like an Arduino or else some microcontroller that has been running in our device, but it doesn't has a capability to connect to the internet. But they can definitely connect with another device like a field gateway. So what is a field gateway? So a field gateway can be kind of an intermediate device which can help low power devices connect with our cloud gateways. So consider a case, while I was in my final year, we were making this, home automation project. So our whole project was being done on an Arduino, and we didn't have any way to, connect with an internet to store the data. So there was a way to do it. I wanted to connect it with my phone to, manage everything for phone. So we were using a Bluetooth, a Bluetooth sensor module via which we can connect our Arduino with our mobile app and do the stuff. The app was something of an was an MIT app. I don't remember the exact name, to be honest, but yeah. So at that particular point, this Bluetooth sensor module and our mobile devices were acting more like a field gateway for us. So in an Azure IoT based solution, the field gate an example of a field gateway can be an IoT edge. So now that we have discussed, IoT devices can be IP-enabled devices or directly connected to the internet devices, or they can also be devices which are not directly connected to the internet, but can connect by with the help of a field gateway. So now all our devices are connected to the internet. What next? So the next thing is these devices generate some amount of data on a real-time basis, and they want to send it somewhere. They cannot store it, right? And Raspberry Pi can store some amount of data. It cannot just store petabytes of data by its own. So they need to store this data somewhere to process it. So to store this data and and process it, we have certain other things. So the next thing is that is a cloud gateway. So what is a cloud gateway? So a cloud gateway, acts like a gatekeeper to receive all sort of data from your IP-enabled devices or IoT devices, as well as it can also be used to manage these devices. Let's say that you're an organization, you have bought some n number of IoT devices to do some certain set of actions. Now the thing is, you are giving these devices on a rental basis to your clients, and if your client is not paying a subscription fee, your subscription fees, you're disabling their devices so that they won't be able to get the benefits or reap the benefits of your devices because they haven't paid for the service. So cloud gateway helps you there. So in short, cloud gateway helps you to receive data from your IoT devices, as well as send some commands or messages to your IoT devices to control them. So that's about cloud gateway. So cloud, let's consider that on a layman's term, you can say that a cloud gateway is moreover like event hub. Under the hood, you can is similar to an event hub, or else and what we say a message broker, which stores your data and can also send back some data to your devices. So the next thing is an event processor. So it's specifically it's not called an event processor, but I mentioned it here because we want to process the data that are being sent from the IoT devices to a cloud gateway. So we can't just let our data stay on the cloud gateway all the time. The message will anyhow just get deleted after a certain amount of time, because a message can only stay at a cloud gateway for a specified amount of time. So we need to process it and store it somewhere, right? So how can we process the telemetry data that are sent to our cloud gateway from our IoT devices? So there are multiple ways we can do it. In Azure, we can do it with Azure Functions or Logic App, or else we can configure something else like a stream analytics job to do this thing. So there are a number of ways. So finally, when you have processed the data, and you want to store it somewhere, you can store it in a Cosmos DB. Or else, if you wanted to, store your data in a cheaper way, you can create blob, a storage account and store all this data inside your blob storage account. So now everything is done, and you want to perform some analytics and insights. You can use time series analytics or some kind of job. Plus maybe you wanted to do some machine learning stuff. You can use Azure ML to do it, and you gather some insights, and you want to show it in a in a graphical way, more like a graphs and charts or something, to gather some insight to show your end users, so the business stakeholders. Then you can obviously connect this data to a Power BI or Tableau, something like this, a visualization tool where you can visualize the data. So that's how a typical IoT solution would look like. Now that we have understood what an IoT solution would typically look like and what are all the components that are associated in this particular solution, let's see what's the requirement. So the topic itself says that we are going to build a soil moisture real-time soil moisture monitoring system. So building a soil moisture monitoring system is a requirement, and that's what it is. We need a mechanism to get alerts whenever our crops need water. So how will you know that your crops need water or your plants need water? Every time the soil moisture level dips below a certain threshold, then you'll be able to know that. But how will we find it? So we are stuck in this requirement phase. So how will we do that? So there are a couple of sensors available out in the market. Like there are a couple of soil moisture monitoring sensors which we can use. So typically these sensors directly don't say about let's say the soil moisture level, but we can get the numbers, like whether our crops need some water or not, by the help of the sensors. So how they work is that it's more like let's say that they are typically dependent upon the conductivity of they pass certain small amount of current inside these sensors, and depending upon the conductivity the conductivity response of the sensors, they are able to identify whether our crops need water or not. Like you know that the higher the conductivity, lower the resistance, right? So it's moreover all the mass over here. So let's say your the soil moisture level or the water present inside your particular in the soil of your crop is less, then the resistance would be high. So the number of resistance in your sensor would be posting really high, maybe around. So again, the metrics is again different. Like we are going to get two kinds of output, analog and digital. So let's consider that we are going ahead with the analog output, and the metrics can be something like 0 to 1000. Let's say that your crops need some water. Then at that particular time, I'm sorry.
Sorry, I think we lost.
Hello.
I am able to hear Ashirwad. I am not sure rest of them.
Yeah, I can hear as well.
Okay, sorry,
Yeah.
you're good now. Thank you.
Okay, perfect.
Go ahead.
Okay, so if our crop didn't have sufficient amount of water, then at that particular phase, the water quantity would be less, and the conductivity would go for a toss at that particular time. So what will happen there is that the resistance level will go up. So in the scale from 0 to 1000, the number can be anywhere about more than 700 or 750. So if the resistance level is more than that, then we need to send an alert to the user and say that your plants or crops need some water. You need to water them right now. So that's the whole thing. That's the whole requirement. That's the solution that we want to make. So how would the proposed solution look like? This is how the proposed solution would look like. So we have an IP-enabled device simulator, which we are going to make using on console app. We'll be leveraging the power of the client SDK of Azure IoT Hub to send telemetry data from our simulator to the IoT Hub. Then we will have an IoT Hub triggered Azure function to process the telemetry data that are present inside an IoT Hub, and then move it to a Cosmos DB to store this telemetry data over there, so that we can perform some time series analysis later in the project if in the foreseeable future we do get the requirement, and then send an email alert every time our condition is satisfied. Like if the resistance level showed by the analog output is more than 750, then we need to send an alert to the user saying that your crops or plants need some water them. So that's the whole flow. So since I mentioned, we are going to use IoT Hub, we are going to use Cosmos DB, we are going to use Azure Function, I'm just going to give you a brief insights about them. So what is an IoT Hub? So an IoT Hub is a part of the whole Azure IoT solution ecosystem. It's a fully managed solution. You don't need to worry about scaling, IoT Hub to handle large amount of data or messages, or you don't need to manage a lot of things over there. So it's a fully managed solution. It provides device authentication out of the box. You can authenticate your device using certificates, or else you can also use certificates to you can use certificates or SAS tokens to authenticate your devices. Second, you can also store metadata for a device. Let's say you're an organization, you're selling IoT devices with certain services to your customer. You want to store some metadata about this device, like this device is associated with this customer. You want to store these kind of associations. You can obviously store that using using Azure IoT Hub. It comes with a built-in registry, device registry, which enables us to store the metadata, to be honest. It provides multiple communication options. It supports multiple communication protocols like MQTT, AMQP, or HTTP. So you can use any of them to communicate from your IoT devices to the IoT Hub. So it provides client and cloud SDKs. Today we are going to have a look at the client SDKs while we are going through the simulator app. The cloud SDK is beyond the scope of this talk, so we may not be able to talk much about it, but definitely in the future we can definitely discuss more in a different talk. It provides first-class integration support with other Azure services. You can integrate your IoT Hub with an event grid, or else an event hub, or else an Azure Stream Job, or else you can integrate it with an Azure function, like we are going to do it in our case. So the next thing is Azure Functions. So what is an Azure function? So it's a fully managed serverless service. So what is serverless? So serverless is nothing but you want to run your code every time your user requests it, then you can consider that that's serverless. Your code should run only when your user wants it to run. Every time your server gets a request, you're going to process it, and the rest of the time the server is going to shut down instead of sitting idle. So that's what serverless is. So it's a function as a service, and it provides you a micro billing out of the box. It's like it's a per second billing. So per second you'll be charged. So the number of time your Azure function runs in your server, only you're going to pay for that, not for the whole time you have provisioned your function instance. So it supports multiple languages. We are going to build our Azure functions using .NET Core. You can build it using Java, Python, and other languages. It supports multiple languages. So what is Cosmos DB? So Cosmos DB is again a fully managed NoSQL DBaaS. So DBaaS is nothing but a database as a service offering. So it's highly scalable, provides multiple levels of consistency, provides enterprise grade security. It means that your data is secured while on transit as well as on rest. Next, it supports multiple APIs. Let's say you're using MongoDB for your workloads, for your data workloads. There is a MongoDB API which you can use and move your data existing MongoDB workloads to Azure Cosmos DB. You just would have to select the MongoDB API while you're provisioning your Cosmos DB account. Let's say you're using Gremlin. You can obviously use the Gremlin API for that. And if you're just creating an application fresh out of the box, and you have that your data workload is going to be NoSQL, but you haven't decided what kind of workload it will be, then you can just create an Azure Cosmos DB account with a core SQL API, and you can query the data in a SQL-like syntax, just like the way we used to query our data from a database using SQL. We can absolutely do that in Cosmos DB with a core SQL API. So the last thing, or the last component that we are going to use to build our service is Sendgrid. So what is Sendgrid? So Sendgrid is nothing but a cloud-based SMTP provider that I'm using. Though the Sendgrid is available as an output binding for Azure Functions, but I will not be using that because it is a paid service, and it's better to use free services when they are available. So let's get started with the demos and with the theories. And the first task would be to create an Azure IoT Hub in Azure portal. So let me go to my Azure portal and search for IoT Hub. So you can just go over here and search for IoT Hub. So let's create one. So as you can see, I don't have any IoT Hub right now. So let me click on create to create one. So I'm going to select the resource group which I have previously created. Let's name it as MSFT R soil moisture. Let's keep the region as East US. And the networking, we want to give public access, and we don't want to put any constraint for this demo. But if you want to send your data on a particular network, then giving a private access would be a better way, and it's also recommended. So here you need to select the tile. So since this is the demo purpose, I'm going to go with the free tile. So there are a couple of restrictions. So it's more like you can send only 8,000 messages, and you don't have the Defender for IoT enabled. So Defender for IoT is a way in which you get more security for your IoT workloads or solution when you're building with Azure. Rest of the things you get everything. Though there can be some constraints with the partitioning, you don't get more than 2 partitioning, I reckon. But you can get those with standard or basic tile. So with basic, you get these things and the cost and everything. You can send more than 400,000 messages per day. But yeah, we are going to go with the free tile. So next is tags. You're building a huge workload, and you're running it in your enterprise subscription. Then it's better to add tags. For it helps in segregating your resources as per the project, as well as it helps in the billing purposes. But we're not going to do this for this demo. It's just going to click on review and create to create our IoT Hub. You can obviously create it using Azure PowerShell or Azure CLI. I prefer the the portal way to do it. but there are other approaches too. So once the deployment is in progress, let's go back to the slide and see what's the next step. We have created our Azure IoT Hub. So the next step is to register our devices in IoT Hub. So the thing is, we'd have to register our devices first inside the IoT Hub before we start developing our IoT Hub simulator that we are going to build using .NET Core. So in the meantime, the deployment is in progress. Are there any questions? I'm open to having any questions while the deployment is going on.
So are we creating a new VM in Azure Cloud for this?
No, we are not going to create an VM instance for this because IoT Hub is a Paas service, and secondly,
Okay.
function instance is a serverless offering, so VM doesn't come into the picture, to be honest.
Okay. So we are directly using this Azure service for that.
Right.
Right. Okay. Okay.
Okay. So let's wait a while. It's taking a bit longer. Okay. It's created. So this is how your Azure IoT Hub screen would look like when you provision it. You can see your tire as well as the host name and everything over here. So your host name or else your IoT Hub name needs to be unique, because there are only limited number of subdomains that would be available with this name with Azure Devices.net domain. So the thing is, when we want to register a device, we would have to go to the Explorer section from the side menu and then click on IoT devices. Now, before running our IoT device, we need to get the SES token or the certificate so that they'll be able to send data to our IoT Hub, because our IoT Hub won't allow anyone out of the box who's connected into the internet to send data to us, because if the number of messages go over, we need to pay money accordingly. So for that, we will have to first register our device in IoT Hub. To do that, I clicked on Add Device. After clicking on Add Device, you need to give a name, so it can be anything. That's the device ID. So let's say I'm going to name it Ashirwad's device. So I'm going to select the authentication type as symmetric key. Symmetric key. You can also use certificates over here like X.509 signed or CS signed certificates. So it's going to automatically generate the key. So that will be more like a SAS token that we normally get when we work with a blob storage or some other queue storage kind of a thing. We get this connection string and everything, and we use it, consume in our applications. So it will be similar to that. Now that the device is created, we can get the token over here. So that's the connection string you can see over here. So we'll be using that. So I'm going to copy it. And before going any further, I would like to add up a couple more services and show you a mechanism in which we can query for devices. Previously I mentioned that it provides an device registry out of the box. So it's more like it stores the list of all your IoT devices. So let's say I'll name anything as reactor device. So I'm going to add it. So I have 2 devices now. I want to add one more. So let's say I name it as Vivek device. So I'm creating multiple services right now. So let's say I wanted to query, the devices. I wanted to know more information about the devices. So how do I know more about it? Like whether they are connected to my IoT Hub, or whether they are enabled or not. So there can be multiple things. So we can query these things using the Query Explorer over here and writing query. So if you're acquainted using Azure Cosmos DB, the queries are pretty much similar over there. So let's click on run. So this will give the result of all the IoT devices that we have registered in IoT Hub. So you get these things like device ID, e-tag, device e-tag, status. So status enabled is moreover like, let's say you have given this device to a particular user, but he is not paying you any money, and you don't want this device to work for him. So you want to disable it. So what you can do is that you can change the status of this device to disable, and this will not allow that particular IoT device to send any data, telemetry data to the IoT hub or to anything with our solution. It's going to block it completely. So that's what status does. And the connectivity state is moreover like whether your IoT device is sending data, IoT device is sending data to our IoT hub right now. So there can be a latency of 2-3 minutes to update this, this value of connection state. But yes, it does say whether your device is connected with the IoT hub right now or not. So these are the kind of things. So here you can see the authentication type is hash, since we were using the symmetric keys. But if we would have used the certificate, then it wouldn't have been null for the X509 thumbprint. Apart from that, these are the metadata about your IoT device. You can add more. Like I previously mentioned that if you wanted to add more metadata to your device, like associating with the user's name or something, you can always add that over here. So these are the capabilities. Let's have a small query, and where is more like we just need the data of a device whose name is let's see, reactor device. We just need the information of reactor device and not the whole thing. So how do we do that? So for that, we will have to select where the device ID is equal to inside single quotes, enter the device name and click on run. And you only get the, the value of the devices, the result where the device name is reactor device. But let's say I wanted to get, the set of devices which are enabled. So it's going to give me 3 results set right now. So for that, I need to select, I need to add status instead of device ID and click on enable and click on run, and it will just give me the result of all the devices that are enabled right now. So you get everything. So now we have discussed how to register a device in IoT Hub and how to query about devices and various metrics. So let's go to the next section. The next section is send telemetry data to the Azure IoT Hub from the device simulator. So for this, I am going to Visual Studio. So you are free to use any IDE of your choice. So I'm using Visual Studio because I'm more comfortable with that. So I've created a couple of set of projects beforehand because my system is pretty unreliable and it takes enormous time to build these projects and showcase demos. So this is a very simple console application. So the first thing you have to do is that you need to create a console application that will be using to send telemetry data as our IoT device emulator. So after you create a console application, the next thing that I would require you to do is that go to manage NuGet packages and add this particular package, that is Microsoft.azure.devices.client. So you need this package to interact with the IoT Hub. So this is the client SDK. So once you do that, there are a couple of things that I need you to do. The first thing would be to create a static instance of your device, of a device client object called of type device client, and then get the connection string. So where will you get this connection string? So, to get the connection string, we would have to go back to Azure portal and go to the IoT Hub resource, and then go to built-in endpoints. So in built-in endpoints, we are going to get the connection string. I'm sorry. So for the connection string, you need to go to the IoT device. So I'm sorry, I messed up a bit over there. So yeah, so the connection string is moreover the connection string that, or the systematic key that we generated while we were registering the device. So I'm going to take this connection string over there and go back to Visual Studio, declare it over there. So I'm just declaring it like this, but it's not the right way to do it. You can store it somewhere in a app setting.json or a secret key or somewhere and do it. But for the demo purpose, I'm doing it. So the next thing is I'm just having a task delay because I'm just keeping it so that it takes a 10-second gap before sending the first message. This doesn't add much value to the whole thing. The real work starts over here. So I'm initializing this device client object over here by using the device client's create from connection string method and passing in the correction string and specifying the transport type as MQTT. But as said earlier, there were other communication protocols which we can use, like MQP, then HTTP, HTTP1, and TCP, MQTT, TCP only, and other things. But I'm gonna let it as MQTT for the time being. Next, what I'm trying to do is that I'm trying to send 10 messages to my IoT Hub, 10 telemetry messages, and for that I'm generating the data. So how am I doing it? I have a method called send message in which I'm sending the device client object, which we had initialized over here. So let's go inside this method, and here you can see that I'm initializing a variable, and just mocking up the data, mocking up the telemetry data, which will be sent by a Raspberry Pi and Arduino. Since we don't have access to the hardware devices, we are prototyping using this emulator, and I'm just simulating the data. In the Raspberry Pi or as an Arduino, we are going to send the same thing. So here I'm specifying the device name, but we can also get the device name using by the help of the device screens. So how do we get that? I'm sorry. So for that, it will be more of a like device ID. Let's say I'm just defining a variable called device name. Then I'll be leveraging the device client object. So in the device client object, what I can do is that get twin async. So what this method will do is that, but for that I will again have to change this method to an async. But the primary thing is, if you wanted to get any information about the IoT device which you had filled in the device registry of your IoT hub, then you can use this particular get twin async method to get all those data. So it's more like if you had registered your IoT device with the name of Ashirwad simulator, you can fetch the particular name of this IoT device from with the help of this device client object, and just pass this value when you're creating your data again. So you can get all those metadata that I showed you, which we're getting in the Query Explorer. So all those information will be available to you. But for the time being, I'm hard coding it over here as Ashirwad simulator. Then I'm randomly generating a value from 100 to 200, but it should be something like 100 to 1000, because the resistance can the analog output of the soil moisture sensor can go from 0 to 1000, but I'm keeping it 100 to 1000 for the time being. So I have this method over here to generate the value randomly. So this is a method, nothing too fancy about it. I'm just passing in two double values and just generating the value, the double value, or else a random output for mocking our analog output from our IoT device sensor. Then I'm getting the result. I'm sorry. Then I'm setting up the moisture level. Then mentioning the date time of now. So daytime is important because when you want to do some analysis, you also need to know, this endpoint was, at what particular time the soil moisture level was then was, this much. So that, maybe later after 6 months or 1 year, when you have seizable amount of data, you want to know at what particular time of the day, the moisture levels goes down, so that you can have this setup in which, every day at, let's say 10 a.m. my soil moisture level dips to a certain threshold where my crops need some water. I can just start my what we say pumps and other thing to spread water across my crops and fields at that particular time. So you can do a lot of insights if you have the time at which the sensor data were captured. That's why the daytime that's why the time at which this value was recorded is important. So we are sending in 3 data right now, that is device ID, moisture level, and recorded rate. So once we assign the values, the next thing that we do is that we serialize them. So we are just serializing them using the Json Serializer class, and then we are encoding it, and then sending in this data using the send event async method of the device client. So it was an async method. I wanted to make it as an what should we say, I wanted it to execute in a synchronous way. That's why I've added the get a writer and get result. So I have added it in a try catch block, because sometimes you can get exceptions. So that's the normal thing. So you need to be, you need to know about this particular method only, the send events async, because anything that you send to your IoT hub goes in as an event, and it has some telemetry data inside of which that you want to send. So in our case, the telemetry data is this. So once you send that, our console application is going to send that message I was delivered, or the number of the message was delivered. So we initialized it as I equal to 0. Let's send it as I equal to 1. get the number of instances that we are sending. So let's set it as the startup project and click on run. And before it start running, you will be able to see that we didn't had any messages yet in our IoT hub. So we can see that by going to the overview section and seeing here that there were a couple of messages that were there because so the messages were a result of the query that we were doing, message used today, but we'll see it anyhow right now, the number of messages that we are sending. So since I had a buffer of some amount of seconds before the whole thing starts sending message, that's why it's taking a slight longer to start, but let's wait and see. The first message is delivered. So there is a gap of 1 second before each message is getting delivered. So I was testing it by starting, the function project as well as the simulator project or the console application project at the same time by, allowing multiple projects to start up. But, the IoT processor function that we had created to process this telemetry data from IoT device was taking a slight longer. So I just wanted to show the flow properly. That's why I'm taking each project as a time. So 6 messages has been delivered and we want to send 10 messages. So 3 more to go, and after that we will see the total number of count, how many messages we have. And then we will have a look at the function project, which will be responsible to process the data and send an email if there is an anomaly using Sendgrid, and then store the data in Cosmos DB. Perfect. So all the messages are sent. Let's close this and go back to the portal and see the number of messages. So here you can see that let's refresh and see the total number of messages used today. Okay, now it's behaving in a bit odd way. It's saying that only 10 messages were used, 8 messages used today. But it takes some time to update it over here. But anyhow, we're going to see it. Okay, so earlier it was 14, now it's 24. So 10 messages went inside our IoT hub. So that's one thing I would like you people to know. Internally, IoT Hub uses an event hub. So if you wanted to use any of the event hub SDKs to process or make a consumer application which can process the data, telemetry data from your IoT Hub, you can absolutely do that. So now that we have sent our data, we have known how we can send data using the what we say the client SDK of Azure IoT Hub. So let's see how we can process that. Let's create an IoT Hub message processor with Azure Function. So I was using a model over here. You can see that I'm creating a soil moisture model. So it's nothing but a custom model that I created. So it's just a model that I created. You can have a different model of your name. So I'm sharing it across both the function as well as the console application project. That's why I added up in a different project, or else this project is only there to represent the telemetry data in terms of class. So this is the model that I'm using to send my data. So the next thing is that we need to create a function project. So what you can do is that you can just go over here, click on add and click a new project, select the function project as your template. So for that, there is one thing that you need to make sure that you have installed the Azure Function Runtime tool. So this is a necessity. Click on next, and you can absolutely create a project. So this is how you normally create a project, right? The flow remains same. So the next thing that you need to do is that you need to, after the function project is created, you would have to add a new function. So the function would be of the trigger type of the function would be IoT Hub trigger. So here you would have to select IoT Hub as a trigger type, and here you can mention the connection string. So the connection string is nothing but the built-in endpoints. So you need to get the endpoint of the default endpoint of your IoT Hub, and assign the value to the setting name that you have mentioned over here by going to your local setting invitation. So you can an IoT Hub can have multiple endpoints too, right? If you wanted to route your messages to a particular endpoint when a particular case was satisfied, then you can absolutely do that. So IoT Hub gives you those leverages too. So instead of message or event, if you wanted to send it to a custom endpoint, then instead of writing messages or / the event, you can write something else. You can mention the custom endpoint that you want to move to. I'm not going to create one because I already have created it. So I'm going to go into the function over here. So a typical function would just contain these things, HTTP client object if you want to make some HTTP client calls. So apart from that, you have your function name. The function name is nothing but the name that you have given to your function while you are creating it. You can always change the function name by changing the function name attribute over here. The next thing is the endpoint and the connection string. So where will you get the connection value or the connection string of your IoT hub? So for that, you need to go to the built-in endpoints and then go to event hub compatible endpoint. Like I previously said that internally IoT hub uses event hub, right, to process the data, to store the data or to ingest the data. So you need to get this particular endpoint and you make sure that it is selected as an IoT hub owner. So you can click on copy over there, then go to your connection string. So here I have mentioned the connection string name as IoT hub con. So I would have to create a key value pair with the name IoT hub con. So I have added it in my local setting, the JSON of my function project. I have created an IoT hub con key and I have pasted the value over there. So since this is for a different endpoint, it's not going to work for this. I have to replace it now. So I'm going to change it. So I have pasted it over here. So just let me know if the font size is really low or if this side is okay. I just zoomed in now, so I was just thinking whether it was small or not. Are the font size good for you all?
Sure, the size seems okay.
Okay, perfect. So the next thing is that we wanted to, send the data to Cosmos DB. So how are we going to do it? So normally an Azure function comes with two set of things. One is a trigger and the second is a binding. So trigger is something which triggers your function or starts your function. Trigger can be any event. It can be like an API call. Let's say we have a API endpoint as xyz.functionapp.com, and that's our API endpoint. And if you make a request to that, make a request to this particular endpoint, then your function should run. Then that's the trigger. The API request is the trigger. Similarly, there are other kind of triggers. So IoT Hub is one trigger. So every time a message goes to the IoT Hub, then this particular function would get triggered. And if the function is not live at the time, this message is gonna get stored in our IoT Hub for a certain amount of time that is already fixed. By default, it's gonna stay for some amount of time, which I'm not able to recall right now. But yeah, it does stay for some time and then it gets deleted. So, if our IoT Hub triggered function is not live till a certain amount of time, then, all the message will be stored over there. And when this function goes live, it's going to process all these messages in particular batches that can also be configured. So that's all about triggers. What are bindings? So bindings are a declarative way in which you can connect to various storage services or the resource of other services. Let's say that you want to get access to the blob content that are there inside a blob storage. You can use a blob storage binding, input binding, to get those data. And if you wanted to write something in that, you can use an output binding for that instead of creating a blob service client, then getting a reference of that container client or the blob client to perform all the operation on the blob. You can just use these bindings. So this is a pretty time-saving way of using this. So similar to the blob service input output binding, we have one particular binding for Cosmos DB. So we are using the Cosmos DB output binding for our case. So to use this binding, we have to install one particular thing called the the webjobs.extension.cosmosdb the SDK. So after document code function runtime code 2.1, I guess, or 3 got released, all the extension were not coming out of the box. So it's like if you wanted to I'm sorry, if you wanted to get the input output binding support for Cosmos DB, you have to go and install the SDK by your own. By going to the Nugget package manager and installing it. So previously everything used to come out of the box, but right now only the HTTP one and the timer one comes out of the box. The rest of the things you need to do it. Since our project was basically an IoT hub, so we got this out of the box, this event hub one. But for the Cosmos DB one, we would have to install it. So you can search for microsoft.azure.webjobs.extension.cosmosdb and click on install and install this particular thing. Then you have to declare the the input binding for this. So it's pretty simple. You just need to add comma, then define the attribute of our Cosmos DB and mention the database name, the collection name. The collection name is let me just show it to you in Azure portal. So prior to this demo, to save some time, I have already provisioned a Cosmos DB account in my Azure portal. So this is a name you can.
May I ask one question? There is
Sure.
one. Yeah, actually, somewhere we were using the connection string and somewhere we were using the endpoint. So mainly, how do we know we need to use the connection string or the endpoints for that connection?
So the thing is, when we want to get the connection string of a device, we need to go to the devices of our IoT hub and get the connection string. But if we wanted to get the data from our IoT hub directly, we don't want to send data to the IoT hub. We want to get the data from the IoT hub. Then we need to go to the built-in endpoints and get the connection string of the IoT hub.
Okay, so both are actually the different things, like a one-way communication or two-way communication, like this.
No. The one-way communication and two-way communication are a different thing. It's more like we were registering our devices, right? So our IoT hub does some authentication to accept data from a device and store it inside of his, in memory or something like that. So for that particular authentication, you need to get a connection string of the device. After you register a device, you're going to generate a SAS token or else a connection string. Let's say connection string. So you need this connection string while creating the device client object, which you'll be creating with the help of the device SDKs of the IoT hub. So for that, you need the connection string of the device to send messages. Now, when you want to process the data that is present inside the IoT hub, you need another connection string. You need to get the endpoint, from which you can get the messages which are already stored inside IoT hub. You don't want to send now. You want to get the data that are there inside the IoT hub. So at that particular case, you need to get the the connection string or is the endpoint URL of the IoT hub.
Okay, got it. Yeah, thanks, Ashirwad.
You're welcome. Thank you. So let's go to the Cosmos DB account. So here you can see that let's go to Data Explorer and see what all databases or containers I have over here or collections I have over here. So here my database name is my IoT DB. So same name over here. Then I have a collection. So that's dev data store. So I just gave it a random name. You can have a standardized name when you're building it up for your production. So the name is dev data store, and currently you can see there were a couple of data items which I populated when I was, testing it out. So yeah, I have a couple of data. So ID, device ID, moisture level, recorded it. So ID is auto-generated, and the rest 5 of them are also system assigned or system generated values. So these are something that we are not generating. So our ID is basically a value in which you can get unique. You can uniquely get this particular item. Self is just what we say. It defines a bit of a metadata about it, I guess. So let's not bother about these 5 values and the first one. We are only concerned about these things because the rest of the things are automatically generated when this particular ID we are generating. I'm sorry. So this is a GUID that we are generating from a function app. But these 5 things are generated by the Cosmos DB when we are inserting any data to a Cosmos DB account. Okay, so we need to define the connection string here as well. So we want to store something in the Cosmos DB. We want to have then we have to authenticate our service, right? We have to authenticate our function app to say that hey, I have got access and I'm an authorized user to store some data over there. So for that, we again need a connection string. So to get that connection string, we need to go to the keys section that is present inside settings of your Cosmos DB resource. Click on keys and get the primary connection string from over here. Click on copy, go back to Visual Studio. So you need to create again create a key value pair with the name dbcon and the value that and paste the value that we have copied here for that. Like I pasted it over here, that dbcon and the account name and everything. So that's about it. The next set of things that we wanted to do was that we wanted to send an email. So how do we do that? So to send an email, I'm using a service called Sendgrid. So as I previously mentioned, you can also declaratively do that. You can just define the attributes of Sendgrid over here define the recipient name and the message body and the subject name and send it. But for that, you need to pay some money upfront. So it's going to charge you for every email. But the funny thing is that Sendgrid gives you a set of free emails that you can send. Like per day, allows you to send 100 emails. So if you're using their SDK, so I thought, why not use that? So I'm using their SDK, as you can see. So I'm using the Sendgrid SDK. So you can just search for Sendgrid. You get the C# client library, just install it. Then you'll have to create an account in Sendgrid and generate your own API key, and then use that particular API key. So that's about all the installation that we need, or the declaration that we have to define at the start of our IoT processor function. So now that we have configured everything, the next step would be to see how we can process the data. So by default, it will be, the message will be encoded. So, it will be in a base64 format, I reckon. So first you have to decode it in UTF-8 format. You can convert it into a JSON string, then then again convert it or deserialize it to a model, the soil moisture model, in which we had defined or created our this data or this telemetry data from our device client. So we have defined, we have deserialized this particular telemetry data. We are getting the endpoints. The next thing is that we are going to check like if the soil moisture level goes above 750. So if the resistance is more, then you need to send an alert, right? So if the resistance is more than 750, then the soil moisture level goes below a certain level in which you need to water the plant. So that should be the case. So let's say that the soil moisture level is greater than 750. You're going to send an email first. So in the email, to send the email, I'm using a send email async method. So this method does nothing apart from just making a call to the Sendgrid API using the Sendgrid SDKs method. Like it's first creating a Sendgrid client using the API key. The next thing is that it sets from whom you're sending the email. Like it's like I'm the sender right here. So I've given my name as admin. I can change it to, let's say, Ashirwad. So then you need to define the subject. So I have defined my subject in my local setting in JSON. So I have my subject over here, email subject. The next thing that I'm doing is that I'm defining to whom you need to send the email. So these are again stored in my local setting in JSON, the recipient email, and then I have hard coded the name over here, but you can always get it from the local setting in JSON. So the next thing would be the content that's there in the email. So I have given it as plain text content for the time being. So that's again also there in the email message part or the email message key of your local setting the JSON. And finally, you can also add HTML content if you have a template in which you want to send that. You can also do that. So you can also store this value inside your local setting.json as well. So we can do all this thing. So finally, I'm using the mail helper class to classes create single email method, and then using the send email async method of the Sendgrid client class to send our email by passing in the message object that we created. So these are the methods that we need to send our send an email. So after we send the email, we want to store this data in our Cosmos DB collection as an item. So item is nothing but a record. That's what we call each records in a Cosmos DB collection that's present in a Cosmos DB collection when we're using the core SQL APIs. But if you use something like a Gremlin or some other API, then the name changes. But yeah, this more of the thing. So to do that, I'll be using this document out object. So this is an iasync collector dynamic object. So the basic thing that I need to do is that it gives me a couple of methods to do it. So I'm going to use the add async method and pass in a dynamic object. I'm creating a dynamic object over here. I could have simply passed, the JSON string that I got over here. Like after encoding UTF-8.getString, this particular thing, I can just paste it over there and store it. But just I wanted to just add a new thing, like just define the ID by my own. That's why I'm using this new keyword and defining a new object of my own, though the value and the name doesn't change much. I'm just adding this ID by generating a new grid for this, and then just assigning the value that we got from our data model after deserializing the object that was sent by the IoT hub. So once we do that, we are just making an async call to that, and that's all. That's how the thing is done. Now that we have sent 10 messages to our IoT hub, let's see how the things are done. I'm going to add my breakpoint over here at the start of this function and see how everything works now. Okay, so I have edited it. Let's set this as my startup project and start it. So one key thing is that you need to install function runtime Azure function runtime code tool in your system to run a Azure function project. So this is something that you'll have to check whether before creating function project, or else it's going to throw you an error. The next thing is that while our function runtime is starting, I'll say that all the things that we have stored in a local setting, the JSON file, when we deploy our function instance to Azure, what is going to happen is that you need to define everything inside the the application settings. You need to create key value pairs over there so that it can your function instance will be able to fetch the value over there. So let's see the flow of the program by going inside. So I got the first message, so it hit our breakpoint. Let's see what the value that we got. Okay, there was some issue with this. So let's see what's the value that we got over here. So the device ID name is the Ashirwad Simulator. So since we got the connection string from this particular device and pasted it in our console project as a connection string, you can see the device ID is this. Then the moisture level that was randomly generated and the recorded date, it was at 5:46 p.m. today, and the second as well. We got those things. So now that it doesn't satisfy our condition, it's not going to send an email. It's directly going to go and just store everything in our Cosmos DB account. So what we can do right now is that we can just remove the breakpoint and let it continue and see how many times this is processing. So I think the breakpoint got stuck somewhere. That's why it's pointing me over there. But yeah, we can see the progress and what messages it it processed and stored in our Cosmos DB account over there. You can always see that over this window. So it was able to process all of this. It got 5 records in a batch. So it was taking the messages in a batch of 5, and it was trying to process them. So you can see the values over there. You're seeing these values because I mentioned this log information thing, and where I was specifying the device ID and the moisture level and the recorded date. That's the reason we are able to see that, or else we wouldn't be able to see that. So now that we have processed it, let's see that whether we got any condition where where we will be able to send an email, like anywhere the moisture level was more than 750. Okay, so everything was below 750, so we were unable to get an email. So what I will do right now is that, so I'm gonna send a custom message this time from my simulator device where the value will be above 750. So I'm gonna give the minimum value as 751. Okay, so instead of sending 10 messages, I'm only going to send one message this time. So let me set this as my set a starter project, and start it and send one message whose value would be more than 750, so that I can show you the demo on the feature of sending email alerts every time the value returned by the analog output is more than 750. So let's wait till this one executes and sends a message to our IoT hub, and then we'll start the function project and see the feature on sending email alerts using Sendgrid. Okay, it's taking a longer time to start the project. This a rare instance. Did it start? Yeah, it started and sent the project. Send a message to our IoT hub. So now what we're going to do is that set our function project as a starter project and just start it off. and see how it gets processed, and we will go to the email account that I had configured, where I'll be receiving the email. So it was able to process this particular thing. It got executed. You can see the value was around 938. So our plants really need a lot of water right now. So the timestamp as well as that. So as you can see that I had configured. Okay, let me just stop my function project and I'll show you what email address I had configured over here. So the email address was ashirwad.outlook.com. So this was my Outlook account. So what I'm going to do is that I'm going to open my Outlook account where you can see the email, whether we got it or not. We should probably get it by now. So yeah, we got it. So I think there was a message in which the value was obviously more than that. That's why we got an email, but somehow I missed it. So yeah, the soil here you can see the message. Hey, the soil moisture level is low and we think it's time to water your plants. Same over here. So we got the emails, all the features are working. So yeah, so we were able to build our solution using a simulator app and then IoT Hub triggered Azure function to process our message. So that's all for the demo. I'll just like to share something about a book that I've recently published. It's on Azure Functions with C#. So this is the link that you can use to go to this, go to the Amazon website of this particular book. And if you're interested in learning Azure Functions, you can always, go and buy this book and just share your thoughts, whether you like the book or not. I'm open to any constructive criticism. I'd love to know more about the feedbacks, and that's all from my side for today's talk. I'm open to questions. Any questions? Okay, I'm sharing the book link. If there are any questions, please feel free to ask right now. I'm pretty much open to answer most of the questions that you have, which I can actually answer.
Actually, trying these things, after trying this, if we got some issues, should we connect to you on
Yeah, sure.
Twitter or anywhere? Okay.
Yeah, you can definitely connect with me on Twitter. And if you wanted the source code of this demo,
Yep.
so I'm gonna share it over here in the chat window. You can find my GitHub repo over there and just get it.
That will be really helpful. Yeah, this is helpful.
Perfect. So this is the
Thank.
GitHub repo. Yep.
Yep. Thank you so much, Avinash. Ashirwad, sorry.
No worries. Thank you, Pura.
Yep. Bye.
Okay. Any more questions, other guys? So I think there are no more questions, Rashmita. Over to you.
Just one question. So this solution can be implemented for other requirements and many other fields, right? IoT-based solution.
Definitely, it's just one of the solution. Like in my previous organization, I was working on a project to to prototype a solution for a healthcare firm in which we were getting some telemetry data from a medical device and processing it. The way was pretty much similar to the way I was building the solution. So you can absolutely do that, but there are other offerings. If you see with IoT Hub, we get a lot of flexibility as developers. We can customize a lot of things. But if you want to do something, you don't want so much customization and you wanted to get started on the fly, you can definitely explore something called the IoT Central.
Understand. Yeah. Great session. Thank you so much.
Thank you. Any more questions, anyone? So I think there are no more questions. Over to you, Rashmita.
Yes, thank you so much, Ashirwad, for the amazing session, and thank you all for joining us today. Please feel free to do event check-in and share your feedback about today's session. It will help us to choose our topics better. Also, please visit Microsoft Reactor Bengaluru meetup page for more upcoming session. We have launched our Samosa and Chai with .NET series recently, and our first session will be on 28 October. I've already shared the link to register for the session. So please register for the session. It would be an amazing one. And thank you all once again, and enjoy the rest of your day. Thank you.
Thank you everyone for joining in. It was
Yeah,
pleasure
thanks.
seeing you all.
Thank you so
Thanks a
much.
lot.
Thanks,
Bye bye.
Bye.
Rashmita. Bye.